Our goal for today is going to be to get through 8.4. May not do the whole thing in this video. I haven't completely decided yet. But we are going to start. So, and yes, we are skipping 8.1 to 8.3. Okay, I'm trying to pick and choose a few things just to cover here at the end that I think will benefit you moving forward. So, 8.4, multiply and divide rational expressions. So this is going to be a whole lot of just canceling stuff to an extent. So simplifying rational expressions. So first of all, we have just this property, I guess you could say. So let A, B, and C be expressions with B not equal to 0 and C not equal to 0. Then the following property applies. So it says AC over BC is equal to A over B because you can cancel out the two C's. Okay, so you basically just divide out the common factor. Okay, that's all that's going on there. Let's see, two more little concept things here. Multiplying rational expressions. The rule for multiplying rational expressions is the same as the rule for multiplying numerical fractions. Multiply numerators, multiply denominators, and write the new fraction in simplified form. So let A, B, and, four letters, C and D, okay, be expressions with B not equal to 0 and D not equal to 0. Then the property says that A over B times C over D is equal to AC over BD. And we would simplify if possible. And then we have the same thing, well, sort of the same thing for dividing rational expressions. So this is the last thing, and then we'll get some examples. All right, dividing rational expressions. To divide one rational expression by another, multiply the first rational expression by the reciprocal of the second rational expression. So remember, we divide by a fraction, we multiply by the reciprocal. So again, let A, B, C, and D be expressions with, now in this case we need B not equal to 0, C not equal to 0, and D not equal to 0. So then this property says A over B divided by C over D is equal to A over B times the reciprocal D over C is equal to AD over BC, and we would simplify if possible. Okay, I know I kind of ran through that stuff a little bit quickly, but that's just the properties that you need to know going forward. But what we're going to do now is actually some examples and see kind of what those are going to look like here. And this stuff is in your book if you need it in that section. Alright, so we're simplifying the expressions. If possible is going to be the first thing, so simplify if possible. So number 6, we have 4x squared over 20x squared minus 12x. So you're probably looking at this and you're thinking, well, maybe a couple different things. You may have done something like this in Algebra 1, okay, but most likely what your first thought is going to be is to go, oh, well, there's an x squared and an x squared, so I can just take that out, and then there's a 4 and a 20, and so I can take that out. No, false, not true. Can't do that. Okay, so we need to rewrite the bottom in factored form, okay? So we're going to do this as 4x squared over, let's see, down here I can take out a 4 and I can take out an x, leaving me with 5x minus 3. So now I have a 4x on the bottom and I have a 4x squared on the top, and since this stuff is being multiplied, now I can take out the 4's and I can get rid of the x's, leaving me with x over 5x minus 3. And that would be the answer. So the big key to this is to factor as much as you can. So factor as much as possible, and that will help you a lot. Okay, let's see here. So something like 8. We have x squared plus 2x minus 24 over x squared plus 7x plus 6. So now, again, remember, I can't just start canceling top and bottom. I can't be like, oh, x squared, x and x, 24 and 6. I can't do that. Okay, I need to factor both pieces. So factor top and bottom. So then this is going to factor into, let's see, I'm just more or less using trial and error, okay? But to factor the top, I need something that equals 2. Positive 6 and negative 4 should work. So x plus 6, x minus 4. That works for the top. And then the bottom, let's see, I need something that does 7, so x plus 6 and x plus 1. So now I have something top and bottom that matches. These x plus 6's can cancel each other, leaving me with x minus 4 over x plus 1. Okay, so you got to get it in factored form, and then you should be able to cancel some stuff. Occasionally, one of them might already be in simplified form. Okay, that is a possibility. Let's see here. Let's look at 12. Alright, so 12, we have x minus 4 over x cubed minus 64. Alright, so this is where we're going to have to remember how to factor out things that are cubes. So let's think about what this would look like. If I pulled out, let's see, I think if we remember Logan's method, this should work for this problem, assuming I'm not mixing something up here. Okay, his method was SOAP. Same sign, opposite sign, always positive. So I think what we should have here is, because let's see, what is this, 4 cubed? 4 times 4 is 16, times 4 is 64. So that's really, we could rewrite this then. We could think about this as 4 cubed, meaning same sign, so I have x minus 4. I'm just factoring this bottom part, and then I'm going to redo the top part. And then here I have x squared, opposite signs, so that means plus. I think this is this middle term, just 4x, and then always positive, plus 4 squared is 16. I think I'm remembering this correctly. It looks right. So, if you forget how to do this, go back and look at chapter like 5, I want to say it was, 4 or 5, somewhere in there. You can look up where we factored this stuff. But, anyways, so now that I can rewrite this, x minus 4 over x minus 4 times x squared plus 4x plus 16. So this x minus 4 cancels with that one, which is good, leaving me with 1 over x squared plus 4x plus 16. And the book says that's what the answer is, so we're good there. Alright, let's do one more of these. We'll do 16. 5x squared plus 18x minus 8 over 10x squared minus x minus 2. Alright, so I'm going to factor these two things separately and then stick them together. So on top, we have this 5x squared plus 18x minus 8. So that factors into, let's see, 40. Need factors that add up to 18. So let's think about this. 40, 5 and 8, 4 and 2, 2 and 2, 4 and 10 don't do it. 20 and 2, that would work. Positive 20 and negative 2. So let's see, 5x squared plus 20x minus 2x minus 8. So I can pull out a 5x here, so that's 5x, so that leaves me with x plus 4, and pull out a negative 2, leaving me with x plus 4. So this is 5x minus 2 times x plus 4. So then let's check out this other one here. So 10x squared minus x minus 2 is equal to, let's see, 20. That would work with negative 5 and positive 4, I think. So 10x squared minus 5x plus 4x minus 2. You can factor out a 5x, so it's 5x. 2x minus 1 Then factor out 2, 2x minus 1. So this is 5x plus 2, 2x minus 1. So then I can combine everything back together here. 5x minus 2, x plus 4, over 5x plus 2, and 2x minus 1. Nothing cancels here, so we say that it's already in simplified form. So I know that's a lot of work to say that it's just in simplified form and we really didn't need to do anything, but unfortunately that is kind of just how it rolls. Let's go ahead and look at a couple more examples here of the multiplying and the dividing type. So this was just simplifying, so now let's look at what happens when we actually go to multiply them or divide them. I'm going to do like 2 examples from each probably. So we have, let's start with something a little bit more simple, like 26. So with this one we have x times x minus 3 over x minus 2 times x plus 3, x minus 2, all over x. So at this point I'm just looking to see what stuff I can cancel out. That really didn't help anything, did it? Something else up there they can... There we go. Maybe? Yeah, there we go. Sorry, sometimes it gets out of focus and you have to do that. Alright, so I'm looking for top and bottom stuff that I can cancel because I'm just multiplying. So I have an x and an x here and everything's being multiplied, so I can do this. So I can get rid of the x's. I have an x minus 2 and an x minus 2, so I can get rid of those 2 things. So this leaves me with x minus 3 and x plus 3, but I need to get it down as simple as possible. So remember, this is a difference of squares. So we have x squared minus 9 would be our answer for that one. So that's a pretty simple one. Let's look at one that's a little harder. Let's look at 30. And then we'll move on to dividing. All right, so x squared plus 3x minus 4 over x squared plus 4x plus 4 times 2x squared plus 4x over x squared minus 4x plus 3. So I'm going to go through and I'm going to factor each piece here and see what all I can cancel out. So let's just start up here. So this is x squared plus 3x minus 4. So if I do a positive 4 and a negative 1, that should work. So I have x plus 4, x minus 1, over down here, x plus 2 times x plus 2, I think should be it, times up here, I can just pull out a 2x, leaving me with x plus 2 over down here, x minus 3, x minus 1. Okay, I'm just factoring all this stuff in my head, so hopefully you guys remember how to do that. That's all that's going on. So now I have everything factored, so now I can go through and I can cancel stuff. So I have, let's see, I don't have anything at the x plus 4 on the bottom. X minus 1, I do have an x minus 1, so I can cancel those things. I don't just have a 2x. I do have an x plus 2, so I can cancel those out. So this leaves me with x plus 4 times 2x over x plus 2 times x minus 3. And because this one isn't something like a difference of squares, I can just leave my answer just like this. I don't need to put anything back together. I actually kind of like it in this form. Here, so just leave it here. Do not multiply through. The only time we multiply through is if it's something like this where it's like a difference of squares and it's pretty obvious. Okay, but if it's as a fraction, just leave it. All right, so that's multiplying. So let's look at the dividing problems then. So that was, oh, I guess I should label this as multiplying. Ooh, that looks awful. Dividing. All right, so dividing here, let's start with a relatively easy one. 36. Not starting with the easiest, but an easier one. So we have x plus 3 times x minus 2 over x times x plus 1 divided by x plus 3 over x. So here, everything's already factored for me. So the only thing I need to do is I have this here. It's dividing, so I need to multiply by the reciprocal. So just so everybody can see, multiply by the reciprocal. So this is going to be x plus 3 times x minus 2 over x times x plus 1 times x over x plus 3. I have an x plus 3 top and bottom, so I can get rid of that. I don't have an x minus 2 on the bottom, but I do have an x on the bottom, so I can get rid of those. So I'm left with x minus 2 over x plus 1. Oops. So once you multiply by the reciprocal, you're doing the same thing as above. So that's kind of the reason why I just kind of stopped doing multiplying ones, because we were essentially going to get back to that here at the bottom. Let's see, one or two more. We'll do 40 and then probably 42 to wrap it up. 40, 3x squared plus 13x plus 4 over x squared minus 4 divided by 4x plus 16 over x plus 2. So the biggest thing I have to factor is this one up here, and that one's going to end up being kind of weird, but 12 is just 12 and 1 is what that's going to end up breaking up into. So this piece, I'm going to factor it here, and then I'm going to put everything together. So 3x squared plus 13x plus 4. So this is 12, and then to get to 13, it'd be 12 times 1. So this is going to be 3x squared plus x plus 12x plus 4, which is going to break into, let's see, so this breaks down into x times 3x plus 1, pull out a 4 times 3x plus 1. So this is x plus 4 times 3x plus 1. So I can rewrite the top as that. X plus 4, 3x plus 1. Now this bottom part, okay, is the difference of squares, so it's x plus 2, x minus 2. Need to multiply by the reciprocal. So x plus 2 over, I can pull out a 4 here, so 4 times x plus 4. So now canceling stuff, x plus 4 can go away. 3x plus 1 stays, x plus 2 can go away. So then this leaves me with 3x plus 1 over 4 times x minus 2. And that's all for that one. And then see if I can wedge 42 in here at the bottom of the page. So 42, x squared minus 8x plus 15 over x squared minus 4x divided by x squared minus x minus 20. All right, so this one is a little different because essentially what I have is I don't really have a fraction per se. It's more of potentially using long division here. I got to check and make sure or see what's going to happen here. So let's go ahead and factor this stuff over here and see what happens. So this is x squared minus 8x plus 15. 15 is 3 and 8, so x minus 5, x minus 3 over, I can pull out an x here. So if I pull out an x, though, this leaves me with, let's see, x minus 4. So then, basically what's happening here is I'm multiplying then by 1 over all this stuff. So this factors into, let's see, minus 5 plus 4, or wait. Oh, I have the wrong sign here. This was supposed to be a positive there. There we go. All right, so then this goes into, or this becomes x plus 4, x minus 5. Okay, so when you have something like this and you're dividing, you just do it 1 over that. Okay, is what you multiply it by. It's kind of weird because it doesn't look like a fraction, but essentially I could just write this all over 1, and then that's what happens when I'm multiplying it by the reciprocal. So now x minus 5's go away. So this leaves me with an x plus 4. I have 2 of those. Okay, on the bottom, so I don't really do anything with them other than I end up with x minus 3 times x, or over x times x plus 4, and then I'm going to square that, so I only write it once. Okay, and then this would be how you'd leave your answer for that one. Okay, so I know this is kind of weird, and just everything with how these are written, but hopefully that kind of makes sense. If you still have questions about something or it doesn't quite make sense, shoot me a message and let me know so I can try to work some more, but I don't want to do a ton because it is kind of repetitive. Basically, it's just factoring and canceling, which is all stuff that we've done. Now we're just throwing it all together. So your homework is 7, 11, 15, and then 25 through 41, every other odd. And I think I counted it correctly so that you actually start with 25 and end on 41, but I'm not positive. If for some reason you end on 39, just end on 39. I think I counted them, but I also may have miscounted. So, anyways, hopefully this helps you, and like I said, if you still have questions, just shoot me a message and let me know so that I can see what we need to work on a little bit more. But have a great day, and only 2 weeks of school left, so woohoo.